Welcome to Tech Teach.
So first we will see is the guided medium. So into a guided medium, basically the guided medium which are those that provide a conduit from one device to another, include twisted pair cables, coaxial cable, and fiber optics. Conduit in the sense it will be utilizing a conductor that should be connecting one device to another device. So there will be a direct connection between one device to another device. So therefore there is a requirement of a guided medium. So in that we are having twisted pair, coaxial, and fiber optical cable. So twisted pair and coaxial cable use metallic copper conductors. So here in these two, it will be using metallic. That metals will be like coppers. They will be using as a conductor, and that accepts and transports signals in the form of electrical current. If there are cables, electrical signals will be transmitted as the data through this twisted pair and coaxial cable. But in the third one, that is optical fiber optic cables. So in fiber optic cable is the cable that accepts and transports signals in the form of light. So the first one that we will be looking at is the twisted pair cables. The figure showing the twisted pair cables are likewise. So here the wires are there. So in that wire will be a conductor. So this conductor will be nothing but copper conductor. Copper will be there as a conductor. This is the copper conductors, and above that there will be a insulator. So plastic insulators will be used. So there will be coated with an insulator layer. A twisted pair consists of two conductors, normally the copper, each with its own plastic insulation. So two cables with plastic insulation and twisted together. So it will be twisted likewise. One of the wires is used to carry signal to the receiver, and the other is used only as a ground reference. So here two wires are there. So one will be used as a ground, one will be the one that will be carrying the signal. So the receiver uses the difference between the two. So these two wires difference will be used as the signal. So one is having the ground, means connected to 0, another one is having the message signal or the data that is in the form of electrical signal. So by doing the difference of these two signals at the receiver side, it will be obtaining the same signal that is sent from the sender. In addition to the signal sent by the sender, one sender on one of the wires, interference or noise and crosstalk. So here interference and crosstalk may affect both wires and create unwanted signal. So there can be an effect of interference and the crosstalk. So suppose why there is a use of twisted pair of cables, why can't we use parallel cables? If we are using parallel cables, what could be the disadvantages? Suppose we are using a parallel cable, okay, and suppose there is a noise source. So this is a noise source, suppose. So if this is the noise source and these are the two different wires, this wire will be having higher effect of noise because this one is separated at higher distance, so it will be having lower effect of. So at the receiver side, this wire will be having higher noise effect and this will be having lower noise effect. And it is saying like the difference. So at the receiver side, difference between the two cables are basically considered as the signal form. So once we do the difference, higher noise minus lower noise, overall there will be a effect of noise. Effect of noise will be there. So to avoid this effect of noise that will be available into the parallel cables, so that's why there is a use of twisted pair. So if we have done the twisted pair, that means if suppose there is a noise source or this noise source is there and here also there is another noise source, similarly some other noise source at in between the stages, so you can just see at this point of time this will be having the effect of noise, higher effect of noise, and here there will be less effect of noise. At this position this will be having higher effect of noise and this will be having low noise effect. So similarly one at a one time one wire is near to the source of noise, another one is away from that. At the next time the vice versa is going to be happening. So at the end of the wire, at the receiver side, both wires will be having almost similar effect of noise on both the wires. So if similar effect of noise are there, so at the end we will be doing the difference. So receiver will be doing the difference. So if we are having the similar noise effect, if we are doing the difference, the noise is nullified basically because of the difference. So because of this twisted pair, the effect of noise on both the wires will be almost similar, and by doing the difference, the noise effect can be reduced basically. So that's why the twisted pair is used. So in twisted pair also, two types of twisted pair are there. One is called UTP, another one is called STP. UTP stands for unshielded twisted pair. STP stands for shielded twisted pair. So what is the meaning of shielded and unshielded? If it is shielded, that means these are two wires are there, twisted pair wires are there, and these wires are having a metal shielding. So this metal shielding further provides the less noise effect. So if we have a metal shielding, it will be having less noise effect. It is having the less noise effect means it is an advantage of the system, but the disadvantage is it will be costly. So that's why STP type of twisted pair cables were only used into the IBM system. So that is implemented by the IBM only. So in all the cases of twisted pair cables, UTP, that is unshielded type of twisted pair, were basically used because this STP type were mostly costly. What is the meaning of shielding? Is that metal casing improves the quality of cable by preventing the penetration of noise and crosstalk. So if we are having a shielding, basically improves the quality of cable by preventing the noise and crosstalk. But it is bulkier. But if we are having STP type of cable, it will be bulkier and also it will be having more expensive. That's why UTP type of cables are mostly used. Okay. So these are the two types of twisted pair cables. So here different categories of UTP cables are given. That category is basically given by the society called Electronic Industrial Association. So EIA is a society. They have given a standard like what different standards or categories of this UTP can be fabricated or can be designed. So there is a category 1, 2, 3, 4, 5, 5E, 6, and 7. So these are the 8 different categories are there. So category 1 is the unshielded twisted pair used in telephones. So these are type 1 category were basically used in telephones. It is having a data rate of less than 0.1 Mbps. It is used in telephones. Similarly, other categories have different use in different applications based on its specification. So there is unshielded twisted pair originally used in T lines. So transmission lines, it will be used. So this is having a data rate of 2 Mbps. Okay. Similarly, improved CAT 2 category 2 uh, improvement on category 2, that is considered as the category 3, is used in lines that will be having a speed of 10 Mbps. Then improved category 3 used in token ring type of networks. So it will be having a speed of 20 Mbps. So these are the different applications that will be used in LAN applications. Okay, so based on the different application criteria, different types of cables, twisted pair cables were used in different applications. So these are the complete list. Some is like UTP connectors. So what different connectors are there? So you might have already seen this RJ45 connectors. So these RJ45 connectors are basically having the UTP type of cables basically. That is unshielded twisted pair type of cables. So here the most common UTP connectors are RJ45. So here RJ stands for registered jack. So RJ stands for registered jack. So RJ45 is a keyed connector. So keyed connector, its meaning is the connector can be inserted in only one way. Type C type of cables are there. So Type C cables, but the one that we can insert it in any direction. But RJ45 is having a keyed connector, so it will be inserted only in one way. So here the performance of UTP type of cables performance measurement of twisted pair cables is to compare attenuation versus frequency and distance. So frequency and distance means at what particular attenuation, at what particular frequency or distance, what is the attenuation. So if we are transmitting a signal, so signal in the sense that will be having a frequency, because we have already seen if a signal is there, it will be having an amplitude, it will be having a phase, it will be having a frequency. So at a particular frequency, what is the attenuation? So to find out the attenuation, we have already seen that attenuation is considered in terms of dB. So dB is it attenuation per kilometer. So dB per kilometer is there. So per distance, what is the attenuation? So if we are sending a 10 kilohertz signal or 10 kilohertz frequency of a signal, then in 1 kilometer, the attenuation will be like they at this value. This is the value at like 5 is there. So we can have like if 10 kilohertz frequency signal is being transmitted for in 1 kilometer, 5 dB attenuation will be there. So attenuation should be low for better transmission. So here different gauge is there. Gauge of the wire basically it is talking about. So gauge means basically it is talking about the diameter of the wire. So if diameter of the wire is high, there will be high attenuation. If diameter of a wire is less, the less attenuation will be there. So this is the graph that basically indicate the performance of an UTP type of twisted pair cables. So it has been observed like after 100 kilohertz, there is a sudden increase in attenuation. So that means if we talk about the UTP type of cables, we should be considering like up to like 100 kilohertz, we can have less attenuation. But beyond 100 kilohertz frequency, there is a high increase in the attenuations. Twisted pair cable can pass a wide range of frequencies. So you can just see from 1 kilohertz to 100 kilohertz. So wide range of frequencies are available. In that, these twisted pair cables can work efficiently with less attenuation. Less attenuation means less noise effect on these cables. So its applications are basically in telephone lines for voice and data channels, DSL lines for high data rate, and also in LAN cables. So it can be in LAN networks, we can use it. Different types of LAN networks that are there is 10 base T and 100 base T. These are the different types of LAN cables. So 10 base T means that can support a speed up to 10 Mbps, and 100 base T means it can support up to 100 Mbps of speed. Next one is the coaxial cable. So coaxial means axis will be same. So same axis is there, so it is coaxial. So two wires will be there. So this one is the one that will be used. So this is the inner conductor. There will be an inner conductor. After inner conductor, there will be an insulator. So with an inner conductor, there will be an insulator. After insulator, there will be another conductor, that is outer conductor. So this outer conductor is also called as shield for the inner conductor. So it will be behaving like a shield. So these shield are basically made up of like some cloth type of or cotton type of material. Above that, this type of structures of wires will be used wrapped around the cloth to basically provide the shield for the inner cables. So it is called outer conductors. It will be having the outer conductor, inner conductor, two conductors will be used. So whenever we will be using a wire, that will be having two conductors. So one will be for sending the data, another will be for grounding. So after this outer conductor, there will be another shield, and overall there will be a plastic cover around the complete shield. So this is the coaxial cable type of cables. So coaxial cables, also called like coax, carry signals of high frequency ranges than those in twisted pair cable because the two medium are constructed quite differently. In the previous one, we have seen like up to 100 kilohertz only, it will be having a better quality. Otherwise, it will be having higher effect of noise, or there is higher noise. Okay, so that's why there is a requirement of coaxial type of cables. So in that case, we can use it for high frequency applications also. It can be used for high frequency ranges. Okay. So instead of having two wires, coaxial has a central core conductor of solid or stranded wire, usually copper. So here again the copper will be used, enclosed in an insulating sheath, which is in turn encased in an outer conductor of metal foil. So this will be the metal foil basically. So metal foil will be the outer conductor. Foil or bread or combination of two. So bread in the sense this structure is basically called the bread. Basically there can be a metal foil, complete metal foil on this wrapped in, or we can have bread. So is this type of structure that is called basically the bread. So or it can be having the combination of both a metal foil as well as the bread structure in terms of the outer conductor basically. The outer conductor wrapping serves both as a shield against the noise and as a second conductor which completes the circuit. This will be having a shield, having like a shield to prevent effect of noise on the conductor basically, providing shield for the inner wire basically from the noise, and the outer conductor is also enclosed in an insulating sheath, and the whole cable is protected by a plastic cover. There are different categories to the coaxial cables. One is like RG59, then RG58, RG11, and it is having impedance. So what is the impedance on it? Like whenever we are having impedance in the sense the effect of resistance. So what is the resistance basically? So it is like 75 ohms, 50 ohms and 50 ohms. Coaxial cables are categorized by their radio government. So radio government rating. So radio government rating, that is RG rating. So this is called the RG rating. So based on the RG rating, which is basically categorized. So each RG number denotes a unique set of physical specifications, including the wire gauge of the inner conductor, the thickness and the type of inner insulator, the construction of the shield, the size and type of the outer casing. So based on this RG rating, if 59 is there, so this 59 will be having different set of inner conductor uh, wire gauge, then thickness of the inner insulator, and likewise. So these properties will be changed for different RG numbers. So based on this categories, it can be used for different applications. So there's like if RG 59 is there, that can be used for cable TV connections. Then RG58 that will be used for thin Ethernet, and RG11 that will be used for thick Ethernet. So here each cable defined by an RG rating is adapted for a specialized function. Specialized function means based on the application to applications. So if a particular application is there that will be requiring low impedance, then it can be using like RG58 or RG11 likewise. So based on the specifications, the name of the categories will be changing, and these categories will be applicable for different applications. So that is for coaxial type of cables. Okay, so next is coaxial cable connectors. So these are called BNC connectors. So you might have seen these into some of the labs, like what this BNC connectors are there. So here the most common type of connectors that is used today is the BNC connectors. So this BNC stands for Pavon Neil Cancelman. So Pavon Neil Cancelman. So this is BNC connector that is developed by these scientists basically. And the BNC connector is used to connect the end of the cable to a device such as a TV set. These BNC connectors can be connected to connect the end device. You can just see there is a whole structure. This it can fit into this point that is given, and then after fitting, it basically rotates to set it completely. So there is a BNC connector. This is called BNC connector. This is BNC T. So BNC T will be the one, like two BNC connectors can connect this, and another can connect here. So this is a T structure. This will be creating the junction. Another one is BNC terminator. So BNC terminator is if suppose there is nothing connected here, so it should be terminated with a ground wire. So that means whatever signal is there, it can't be reflected. So there should be a directly terminator should be connected. So BNC terminator that is used to connect with the ground. So BNC T connector is used in Ethernet networks, to branch out to a connection to a computer or other device. So for creating a branching, BNC-T is used. BNC terminator is used at the end of the cable to prevent the reflection of the signals. So if it is kept open, there will be a reflection of signals, so it can create a noise effect on the signal. So that's why it should be grounded. So that is used BNC terminators. Next, we will see the performance of the coaxial cables. So here, the performance that we will be measuring is basically similar to the one that is used for twisted pair. So for twisted pair, we basically focused on like what is the attenuation at a particular frequency per kilometer. The attenuation, so that is like at lower frequency itself up to 100 kilohertz. We are having initially it is having like low attenuation is there. As we are going to increase the frequency, attenuation is going to increase. So and also it is like given here this as the diameter of coaxial cable, like inner and outer cables are there. So its diameter is given. As we are increasing the diameter, you can just see attenuation is going to reduce. In the previous case, we were using like if we are going to increase the gauge size of the diameter of cable, the attenuation is going to increase. But here, if we are increasing the diameter, the attenuation is going to reduce basically. So the attenuation is much higher in coaxial cable than in twisted pair. So in case of attenuation, you can just see in comparison here up to 100 maximum. Suppose this is the gauge, we were having the 10 dB per kilometer attenuation. But you can just see here at 100, the attenuation you can just see at 100, the minimum attenuation that can be there is around like 70. So if we talk about this one, very high attenuation is there. So from the graph itself, it is clearly visible. The attenuation is much higher in coaxial type of cables than the twisted pair. So here attenuation is much higher. So in other words, we can say although coaxial cables has a much higher bandwidth, the signal weakens rapidly and requires the frequent use of repeaters. It is going to attenuate the signals at very high rate with respect to the distance. So that's why there is a requirement like we should be focusing on the use of repeaters. So repeaters will be the one if the because of the noise, the signal strength have weakened, then we need to use the repeaters so that it can increase the strength of the signal. So there is a requirement of repeaters into the coaxial cable type of transmission medium basically. It provides higher bandwidth, but it is having very high attenuation, but attenuation should be low. So that's why there is a requirement of repeaters into the coaxial cable. Its application is analog telephone networks. Might have seen like once we connect the antenna cables into the TV, that is basically the dish TVs, they are having a single core into the medium, that is a single wire, and outside that there is a mesh type of structure. Okay, so that is the second wire and the first wire. So first wire is basically the core wire, but basically that is in the center of the system wires basically. So that's why it is called in telephones. Okay, and used in cable TV networks also. So in analog telephone, it can carry 10,000 bytes per voice signals at a time. And in digital telephone networks, it can carry up to 600 Mbps data. Nowadays, the Ethernet were very fast, but in traditional Ethernet LANs, this coaxial cables were used, but nowadays the fast LAN networks are used basically. Next, we will see the optical fiber optical cables. Fiber optical cable basically works on use of signals in the form of light. We will be using light as the signal. So we will not be not using electrical signal. So electrical signals are not used. Light is used as a signal. So once light is used as a signal, so how it is used, we will just see the basics about the bending of light basically here. Fiber optic cable is made of glass or plastic. So it can be made up of glass and plastic and transmits signal in the form of light. So here the light travels in a straight line as long as it is moving through a single uniform substance. So we already know like if light we have seen, it will be moving to a straight line in a particular medium. But if it has been observed like if there is a medium change, there is a bending of light is there. So here more dense medium is there and this is lesser dense medium. So if light is incident from more dense area to the light dense area, the medium, there is a bending of light. So this bending of light is given by different types. So this bending of light is basically called refraction. So if the incident angle is less than the critical angle, this will be the resultant one. And if the incident angle of the light is equals to critical angle, still it will be called the refraction. And at that time, the reflected angle will be the 90-degree. If incident angle is greater than the critical angle, at that time there will be a reflection. So there will be a reflection. This criteria is basically used into the optical fiber cables. So the signals that will be sent, that will be having incident angle, that will be having more than the critical angle, so that the waves or the light, instead of going out into the second medium, it will be reflected back into the same medium. So likewise, this total internal reflection criteria will be basically used into the transmission of light as a signal into optical fiber cables. So here in optical fiber cables, there will be a sender and there will be a receiver. So and in between the sender and receiver, sender will be producing a light signal that will be with respect to our message signal. It will be converting it into light, and this light will be passed through the optical fiber. So this optical fiber will be having a core. So there is a core that is the inner medium, and outer to this there will be a cladding material. It will be having a different reflective index, or basically refractive index we will call it. Okay, so this core will be having high refractive index. So refractive index is basically represented by n. So core, the refractive index of core will be higher than the refractive index of cladding. If this is the condition, then if we incident the light higher than the critical angle, then there will be a total internal reflection and the light will be sent to the core and the receiver side. The same light will be received and it will be converted from light to the mass signal. So this is the basic idea of the optical fiber. So optical fibers use reflection to guide light through the channel. A glass or plastic core is surrounded by a cladding of less dense glass or plastic. So these are made up of glass or plastic. And also this one will be made up of glass and plastic. The difference in density of two materials must be such that a beam of light moving through the core is reflected off the cladding instead of being refracted. So it should be reflected instead of being refracted. So that means I should be greater than the critical angle. So that should be the condition. Note is like the critical angle is a property of the substance and its value differ from one substance to another substance. So the refractive index is basically defined for a particular type of material. So if a different material is there, its refractive index will be different. So here different propagation modes are there in through the optical fibers. So these different modes are defined by like, if the different modes are like, one is called multi-mode transmission and a single mode transmission. So into a multi-mode, there is a step index or step index fibers or graded index fibers. So we will just see like what is a step index and what is graded index. So here the current technology supports two modes, multi-mode and single mode. For propagating light along optical channels, each requiring fiber with different physical characteristics. For multi-mode and single mode, different type of optical fibers are basically used. They will be having a different physical properties so that they will be supporting either multi-mode or single mode. So multi-mode can be implemented in two forms, that is step index and graded index. So we'll just see what is step index and graded index. So with the help of figure, we can easily figure it out. Like if it is a multi-mode, here the multiple beams move through the core in different paths. So if it is multi-mode, multiple light beams can be passed. So multiple light beams means it can support more signal transmission at the same time. So that will be multi-mode type of transmission through optical fiber. So the first figure A is basically showing the multi-mode. So multi-mode means there are more than one signal or is able to transmit. So one is through the middle of the core, then there is another signal, then this one. So there are total three signals that are being transmitted at the same time. So that will be the one. So here it is source and this is destination. So at the destination, all the signals will be received. So this is multimode. So into that multimode also there is step index fiber. There is a core and there is a core and cladding. So if into the core itself, if we are moving from center to away from the center, so if everywhere into this core, if suppose this is the cladding, so into this core itself, if the refractive index of the complete core material is uniform throughout the core material, then that will be called step index type of fibers. If any material is there, it will be defined with respect to its refractive index, or basically called the N, or the refractive index that we basically see, or the N value. So if this N value or refractive index is basically constant throughout the center and edge. So between center and edge, if the refractive index is constant, that will be called step index fibers. So in multimode step index fibers, the density of the core remains constant from the center to edge. So refractive index, in the sense that will be refractive index is basically going to define by the density of the material. So if refractive index is constant, means density of the material is constant throughout the core or throughout the material. So that will be called the step index fiber. So into step index fibers, the reflection or the reflection, total internal reflection will be taking place directly at the boundary. There will be, because there is no change, because the change in path of a light will be taking place only when there is a medium change. So if it is high refractive index and this is low in refractive index, so if light goes, it will be only changing if there is a change in density of the material or change in the refractive index. So if there is a high and this is low, so at this point there will be change in the direction of the light. It will not be going straight. There will be a change in direction. This change in direction can be likewise. Okay. So this change will be taking place when there is a change in density of the material. So but in step index, the core is having the similar density. So light will be starting from here, it will go up to here. At this boundary, there will be change in density. So there will be a bending of light will be there. So that is the step index. So that is the multimode step index fibers. So another one is graded index fibers. So in graded index, its meaning is the density from going to center to the edge will be keep on changing. So means if suppose this is the core and this is the cladding, so in core itself there will be, and this is cladding. So in core, from here to here, there will be change in the refractive index. Means if a light is coming, suppose if a light is coming, so once this light is coming, so at each point there is a change in refractive index. So if there is a change in refractive index, suppose this is the center, so change in refractive index means after going this location, at this location there will be change in refractive index. So there will be a bending of light. Then again there will be bending of light. That means bending of light. Okay, so that means instead of going straight, the rays will keep on bending very little with very little amount. Okay, so it will not be a straight line, it will be having a smooth curve. It will be showing a smooth curve. So this smooth curve is because of the varying densities inside the core itself. So core is not having the constant refractive index, it is having varied linearly increasing refractive index. So in the sense, You can just see, suppose this is the core. So here you can just plot the refractive index. Suppose at the center, if this is the center is having this refractive index, then it will be keep on increasing, you can say. Okay. So it is not constant, it is keep on increasing. So likewise, you can consider the graded index. So that's why the light will be not following the straight line path. It will keep on a smooth curve, because at each point into the core itself, there will be a bending of light is going to take place. So here, high density is highest at the center of the core, and that decreases gradually to its lowest edge. So you can just think going that way. So suppose there is a core. Okay. So at the center, the density will be high, and at the, okay, you can just see. So refractive index at the core will be high, and at the center of the core will be high, and at the edge will be low. So this is how the profile of the density will be looking like for graded index fibers. Similarly, in case of this step index, whatever is the density, so if this is the core basically, okay, so this is the core, so its density or the refractive index will be constant throughout this. It will be constant at whatever value it is, it will be constant. So that will be the effect of uh, densities on the mode of optical fiber operation. So it is multi-mode, step graded, another one is or step index basically, and another one is multi-mode with graded index. So multiple wave lights will be there, but its path will be smooth, and it is having the straight path, and it will be having total internal reflection at the edge of the core and cladding. The single mode, another one is the single mode type of transmission into the optical fiber. So it basically uses the step graded or step index type of fiber. So step index means there will be a step index fiber. There will be a constant refractive index throughout the core, or there will be constant density. So density will be constant throughout the core. But here you can just see in the figure, it is having higher diameter. Diameter is high, but here the lower diameter of core is high, and here the lower diameter of core is there. So it is single mode. So single mode means only one light source or only one light will be passed through this core. So that's why it is made with lower diameter, because it needs to support only a single light source. But in multi mode, its diameter is higher, so that it can support more light sources. Okay. So here single mode use step index fiber, uh, and a highly focused source of light that limits beam to a small range of angles, all close to horizontal. So here the instant there will be some incidence angle, but here the incidence angle that will be considered, incident angle is 90 degree. Like here the incident angle is likewise. So it will be such that the light will be directly in going through the middle of the core path. So it will be going straight, that is there. So a single light will be going. So at the destination, these having multi-mode, so multiple signals will be received at the destination. Here a single signal will be received at the destination in single mode fiber. So this is the basic about the optical fibers. So the next is the types of optical fibers. So different types are there. This is given specifications are there. Okay. So these specifications are basically going to tell us about the diameter of like core and cladding materials basically. So type 50 by 125 means 50 micrometer is the core and 125 micrometer is the cladding. it will be supporting the multi-mode and graded index. Graded index means there will be variation in the core from the center to the edge, and it will be supporting multi-mode. Another one is single mode. So single mode is there, so it will be having a core diameter like 7 micrometer and 125 micrometer. So optical fibers are defined by the ratio of diameter of the core to the diameter of the cladding, both expressed in micrometers. So its category or its type is basically defined by the ratio of core and cladding diameters. Note that the last size listed is for single mode. So if it is 7 by 125 is there, it will be basically supporting only single mode fiber transfer. Next is the fiber construction. So how it is constructed, we can just see here different components are given. A glass or plastic core will be used, and just above that there will be a cladding. So core along with a cladding. So that will be together. There will be no separation in between that. And after that, there is a plastic buffer is there. So plastic covering will be there. After that, there is uh, Kevlar. Kevlar is basically used. So Kevlar is a material that basically provides a strength. So this Kevlar is used into bulletproof jackets basically. So this is basically used here to provide a strength. And there will be an outer jacket. So there will be the one that will be the outer jacket. The outer jacket is made up of either PVC or Teflon. Inside the jacket are Kevlar. Kevlar strands to strengthen the cable. So there will be different threads of Kevlar material. This Kevlar is a strong material used in fabrication of bulletproof ways. Below the Kevlar is another plastic coating to cushion the fiber, and the fiber is at the center of the cable and consists of cladding and the core. And the next is like optical fiber connectors. So there are different types of optical fiber connectors that is basically represented by like subscriber channel SC connectors. So this is the SC connector that will be used for connecting the different optical fiber cables, that is basically used into the TV cables basically, or cable TVs basically. It uses a push-pull locking system. So once it will be pushed, it will be fixed. So if we are having networking devices to form a network, we are using the optical fiber to connect different network devices. Then we will be using ST type of connectors. It uses a bayonet locking system and is more reliable than SC type of connectors. Basically, this one is more reliable. And another one is MTRJ connectors. So MTRJ connect is a connector that is the same as the size of RJ45. So whatever the RJ45 is there, it is having same size as RJ45 type of connectors. So these are different types of connectors. And next we will see the performance. So here in case of performance, so here loss is given, that is same, the attenuation is given in terms of dB per kilometer. So first of all, there is no attenuation. So it is basically the optical fibers are basically free from the attenuation. Attenuation is because of the noise. So but in case of optical fibers, there is no noise effect. There is no effect of noise on optical fibers. So that's why there is some loss. So once it is transmitting through the optical fiber, there can be a loss. So that loss can be with respect to like different wavelengths is given. So what is the wavelength of light? So because here frequency is not given, it will be in terms of wavelength. So because it is light, so its wavelength will be defined. So for different wavelengths, so loss is given. So its loss you can just consider. So loss is maximum loss is ranging up to like 10 dB per kilometer. And the minimum is, you can just see very less loss is there. So in terms of noise effect in optical fibers, very less is there. Very less noise effect. Okay, so attenuation is flatter than in the case of twisted pair and coaxial. So very less attenuation effect is there, or loss is there. The performance is such that we need fewer, actually 10 times less repeaters when we use optical fibers. So in case of coaxial type, we were using the repeaters, but here we will be requiring like in suppose in coaxial cable, if we are using per 5 kilometer, one repeater is used. Then in case of optical fiber, there will be for 50 kilometer one repeater will be used. So this is the case into the optical fiber because there is very less loss with respect to per kilometer distance. So that's why up to 50 kilometers, whatever loss it will be incurring, the same loss will be incurred by the coaxial cable in 5 kilometers only. Okay, so that's why it is very low noise effect is there. Its application is found in backbone networks. So the one that will be connecting the base network, that is the one that will be basically utilizing the optical fibers, and it's wide bandwidth and is cost effective. So here it's supporting wide bandwidth means large frequency range is there. So in case of wavelength, if we talk about, there will be very high wide bandwidth will be there in terms of band possible supported wavelengths. Okay, so its example is our application is in Sonet type of networks or cable TV networks. In cable TV networks, it will be used as a hybrid network in coordination with the coaxial cable. So along with the coaxial cable and the optical fiber, both are hybridly used into cable TV network. And also for fast Ethernet lines, these optical fibers are used. So there's 100 base FX and 1000 base X is basically the categories of LAN cables. So there are some advantages of optical fiber and disadvantage is given. Advantages like higher bandwidth, less signal attenuation, we have already gone through. Immunity to electromagnetic interferences because the electromagnetic waves or electromagnetic noises cannot affect the fiber optic cables because here in fiber optic cables the signal is in the form of light. So that's why EM waves or EM noise can't affect the signals of the optical fiber basically. So that's why it is more immune to electromagnetic interferences. Resistance to corrosive material means it is uh, because it is made of glass, that is more resistant to corrosion than the copper material, and also it is lightweight and greater immunity to tapping. So tapping here, what is the meaning of tapping is like, so if a if an antenna is there, so antenna is nothing but made up of metals basically. Even the if coaxial cable and twisted pair cables are made up of metals. So these metals can be working as an antenna. So this effect of metals being worked as an antenna is called tapping effect. But in case of optical fiber, there is no metals, so it will be having immune to tapping effect than the copper cables. So copper cables create antenna effect, so it will not be having antenna effect that can be easily tapped into the optical fibers. Disadvantage is installation and maintenance. So optical fiber cables is relatively new technology and its installation and maintenance requires expertise that is not yet available everywhere. So its installation and maintenance is very complex and unidirectional light propagation. So it's like if light is there, but it's transmitting, it can transmit in only one direction. It can't be if it is reflected or if it is it cannot be diverted into two different directions. So propagation of light is unidirectional. So that can be one of the disadvantages. If we need bidirectional communication, two fibers are needed. So that will be more costly. And also in terms of cost, so this is a very high cost, relatively higher than the coaxial and twisted pair. So this are relatively more expensive. So this is one of the disadvantages of the optical fibers.